Hello, my name's Chris Drummond and I'm a coastal engineer at the UNSW Sydney Water Research Lab, which is based in Sydney, Australia. So today I'll be talking to you about a low-cost camera system that we've developed to understand what we're terming the business of the beach. And what I mean by that is to understand things such as shoreline change as a result of coastal storms, but also a new and emerging field, which is the use of machine learning to understand how many people visit different beach locations and how that impacts on how much value we place on the coast and how it varies in different places around the coastline. And so as a bit of a background, if you haven't heard of the Water Research Laboratory, we're part of a university based in Sydney, Australia, and we have a very long track record of using a number of techniques to understand coastal change. And one of our more successful programs is the use of cameras placed on high-rise buildings to understand coastal change up on the Gold Coast. And we've been monitoring coastal change on the Gold Coast for over 20 years using cameras. And there's an example there on the title slide of one of our systems. Now, one of the things that we've figured out through that monitoring program is that it's quite difficult to establish power and communications for these systems. Something as simple on first thought as hooking up a camera to a power system and negotiating approvals from a building manager to put cameras on the roof is actually quite difficult and takes a long time and therefore takes quite a lot of costs. Also, connecting internet to these systems can be quite frustratingly slow at times. And one example of our most recent connection at a place called Drummond on the Gold Coast, it took me over 18 months to negotiate the connections of a new internet connection. So these processes can take up a lot of time and resources. And so we saw that there was really a need in the market for producing a much lower cost system that was a lot more flexible in how easy it was to install. And that will be the system that I'll present to you today. So just acknowledging a number of my co-authors that have been working with me on this system. You'll notice Dr. Mitch Harley is also presenting at this conference, at this forum about the use of CoastSnap for citizen science. So I encourage you to see his great work and a number of my other authors that have been involved in the study. So just as a bit of a presentation overview, today I'll go through 4 different parts of the system. First of all, I'll introduce the system and what it can achieve. I'll then touch on the theory behind the use of machine learning for people counting. And then I'll use 3 case study results on the Australian coastline to talk about what the system can provide. And lastly, data is key, but finding a meaningful way of presenting the data is really important. So I'll touch on some dashboards that we've used to portray the information. And the image that you can see on the right there is an example of some people counting at my hometown where I grew up. And I was really excited to be able to bring this technology to a beach that I've spent quite a bit of time at. So first of all, what is the low-cost system that I'll be presenting today? So the WRL BeachStat system comprises a very low-cost camera system. They cost about 700 Australian dollars to purchase. And essentially all they are, it's one of these cameras you can see in the video here. It's a repurposed hunting camera or trail cam. So these systems are generally designed to be put out in a bush location in areas to look for animals, but we're just repurposing them for beach locations. And what's really powerful about these camera systems is they come with a solar panel so they can operate indefinitely. And they also are able to transmit data via the cellular mobile network. So they've got a SIM card in them. And they are limited in what they can transmit, but we've found the sweet spot is they can transmit an image and a 10-second video grab every 15 minutes. And the fact that they're portable and completely self-contained means that you can overcome a number of the barriers that we've seen in establishing more sophisticated camera network systems. So by avoiding the need for power and comms, you can install them very close to the action at beach locations. And we've had a lot of success installing them on lifeguard towers or on telegraph poles, or even on tree locations. And they're a really valuable tool in understanding the economy of the coast. And you can see the example on the right here where I've hidden it inside what we call in Australia a possum box. And the reason I did that was because I was a bit concerned that surfers at this location would vandalize or destroy the camera system. So I hid it in plain sight, so to speak, in a box that looks like a bird box or a possum box. So why is it so useful to understand shoreline monitoring and people counting? So I suppose I'll be preaching to the converted in this forum about the value of understanding shoreline change at coastal locations. It helps us build resilient systems and understand how we can respond to coastal storms and how that may change under climate change conditions. But not a lot of people consider the value of understanding people counting at the beach. And we've found this to be a very valuable metric in the Australian context because a lot of money is spent in protecting different parts of coastal regions, but not a lot of thought goes into what is the amenity of these different locations to coastal communities. And so we've found it to be very valuable to understand what certain times of the beach, what are the most popular times for people to visit the beach, how many people are visiting each beaches, and you can associate an economic value with a visit to the beach. But also you can look at things that like how might beach amenity change under future sea level rise conditions. So first of all, let's touch on the use of machine learning for people counting. So to start with, we'll talk about the basics of object detection. So machine learning has come a very long way in recent years in what it's capable of achieving. But in its essence, there's three real steps to training a machine learning model to detect an object. The first thing you've got to do is you've got to annotate a lot of data. So in this example, you can see here, it's quite topical. I've built a detector that looks for masks or no masks. And so the first step is to draw lots and lots of boxes around the different classes that you're interested in detecting. And once you've done that, you then train a machine learning model into what to look for. And then once you've done that, you can run your trained model. And in this example here, you can see I'm being quite silly and trying to trick my machine learning model, but failing quite poorly. And with this particular model, I trained it in three classes: a mask, no mask, and the third one is a poorly fitted mask. So this one's performing quite well, but let's have a look. We're interested in the beach, so let's have a look at what we could use these types of models for in a beach location. Forgive my silly antics there. I was going a bit crazy being in lockdown that we've had in Australia here. Okay, so moving things to a beach context, if you feed a picture like this into a machine learning model, the output that the model might present is something like this. In this example of a picture on the Gold Coast, we've detected 47 different people objects, and the model gives a bounding box around each of those detections, and it also gives you a confidence of each detection. For example, this person here, it's 87% sure that it's a person, but conversely, this person sitting down, it's only 36% sure. And you can use that confidence in order to filter out what the model is very certain is a person versus not. And one of the real key points with machine learning models is that we're able to adapt pre-trained models. So there has been quite a significant effort has been put into training models to detect people in the context of driverless cars. So using a camera on a car, you're able to detect whether a person is there or not. And there has been a lot of effort in the research community to build these training data sets where there's lots and lots of boxes drawn around people. An example is a group in China spent a year drawing 500,000 boxes around people. And as a result, we can adapt our models. We don't have to start from scratch. We can adapt models that have already been trained that are pretty certain that it knows what a person looks like, but we just adapt them to different contexts, such as detecting people in a beach context. So a couple of things about detection accuracy. A number of factors impact the accuracy of the model. The first one being how big in pixels are the people that you're trying to detect. If a person is really large in the foreground, it's much easier for a model. And that's why we've had a lot of success with cameras that are close to the action down on beach locations, where we had limited success where the cameras are all the way away on the top of a high-rise building. The next thing that impacts on detection accuracy is how big is the training data set that I've trained my model on. Do I have lots and lots of boxes around people or few? Generally speaking, we need at least 2,000 to 5,000 boxes around each class in order to have a good model. The next thing is, what is my model trained to detect? So we've had a lot of success counting people on the dry beach that are sitting or standing. That's fairly easy, but it's a lot more difficult to detect people that are in the water, that are swimming or surfing, because they tend to be a much further distance away and they're often obscured. But you can see that we've got an example there on the right there of some detections at a local beach, and we're doing quite well with 2 classes. In this case, people on the dry beach in the red boxes and surfers in the water in the blue boxes. And you can see a little plot here of how that varies throughout the day, with swimmers in blue and people on the dry beach in orange, and how that varies throughout the day. But more importantly, how much accuracy do we need when we're looking at counting people on the beach? So here's a plot here of manual counts of people on the beach throughout a 24-hour period, with the manual counts in the dash blue line versus the model's counts in the solid blue line. And I'm sure you can see that there are some discrepancies between the two. But when it comes to counting people on the beach, all I'm personally interested in is consistency. So here you can look as an idealized orange line of what are the general trends in beach visitation. I don't personally mind if I'm not 100% accurate in counting people in a beach. It's more about what are the trends. And if you think about the context of driverless cars, it might be really important that you don't miss a person, because the consequences can be quite catastrophic. But in a beach visitation context, you can relax your tolerance a little bit with how much accuracy you require. And I should also note that the models are consistent. So an alternative data source in beach counts tend to come from lifeguards. And one thing that I've noticed is there's quite a bit of variability in how one lifeguard might count people on the beach versus others. One person might take it very seriously and meticulously count every person, whereas another might be a bit blasé and just say, oh, there's 20 people on the beach. Whereas the machine learning model is consistent. So let's have a chat about some results from the smart camera system and have a look at it. So today I'll present results from 3 different locations up on the east coast of Australia. And to start with, we'll dive into the Gold Coast and look at Burleigh Beach. So the Gold Coast is a very popular tourist location in Australia, and millions of people flock to the area every year. And as a result, the economy is really quite based upon tourism income. So we conducted a trial where we installed one of our camera systems on a lifeguard tower and looked at a narrow field of view directly where the lifeguards put their flags up for swimmers. And you can see here's the camera system here, just mounted on the lifeguard tower. So this particular model, we used a pre-trained model. So we didn't bother custom training a model. We just used a model straight out of the box, and that gave us 1 class only of people. So we installed it at the end of last year in December 2020, and it ran for about 6 months. And there's the view of the camera there. So looking at the output, you can have a look at detections throughout a period of time with the plot down the bottle showing you how many people are there. There was a coastal storm moving into the Christmas period, and the visitation dropped off. And then now as we move into the Christmas period, there was quite a lot of beach usage and a lot of people for visiting this particular location. So that's a bit of a time-lapse view of beach visitation at this location. But let's dive into some of the nitty-gritty data results. So one of the things that I've found a lot of value in interacting with this type of data is using Power BI. So if you haven't come across it before, it's like Excel on steroids, where you can really dive in an interactive way to look at trends in your data. So here's some plots here where we're looking at what's the busiest time of the day on the left and what's the busiest day of the week. So over the 6-month period of the deployment, we can see that the busiest time of day was around 11 a.m. in the morning. There was still quite a lot of people in the morning around 6 a.m., but it really peaked at this 11 a.m. Time of day. The other thing you can do is you can do plots of what's the maximum temperature here. So in the red here, we've got the maximum daily temperature, and then we've got a bar plot of the total visitations. And you can see some really interesting trends about hot days coinciding with lots of beach usage. You can also have a look at things such as what's the busiest day of the week, which you can see here. Obviously, the weekend in this location was very, very busy compared to midweek. And you can also have a look at how it varies throughout the day. And this type of information is really useful from a number of reasons. Think of lifeguards and improving beach safety, knowing when you need more lifeguards on the beach, but also understanding what I'm calling the fingerprint of each beach. And that changes with different locations. Different beaches have different ways and peaks of when people visit them. So just touching on a few things, the busiest day was in January, just after Christmas, where it was also a very hot day. You can also have a look at the busiest day of the week was on the weekends, and also the busiest hour of the day was mid-morning. So for my next case study example, we'll jump much further south to a place called Wombrel Beach, which is just 100 kilometres north of Sydney. So in July last year, in 2020, a very large coastal storm eroded this particular stretch of the coastline. And you can see the example video there where the houses are very, very close to the active beach zone, but there is no coherent seawall at this location. It's just very ad hoc rocks that have been dumped in front of beachfront properties. But fortuitously, we had 2 smart camera systems that were deployed that were able to monitor the response of this beach throughout the storm event and also its recovery in the preceding months. So let's have a look at the results of the smart camera system. So our camera system is looking north towards the area. You can see this is where all the action happened, where the beach was eroded. And then you can see quite a bit of activity where there was an emergency response where a number of rock bags were placed in front of the homes as an interim emergency stabilization. So we were able to monitor using these videos information that was quite valuable in looking at how the beach responded. And I should note that having a picture of how these coastlines respond gives you a lot more information that a conventional survey technique such as a drone survey or an RTK GPS survey may not give you. A picture truly does tell 1,000 words, and you're able to see things that may be missed with conventional survey techniques. So let's have a look at how this beach responded to the storm event. So here's 2 shorelines a week apart after the storm. So you can see that the beach receded on average 26 meters along this part of the coast. And the peak recession, the beach receded up to 34 meters. And that was about 150 meters north of the camera in this area around here. So that's how the beach responded to the actual storm event. But let's have a look at how the beach recovered after that event, which is an emerging area of research that we're slowly starting to learn a lot more about how our beaches recover after these types of events. So here's a plot of beach width in the lead up to the storm. So you can see that there was some natural fluctuations in the beach width up into the storm event, which occurred around here. Then the beach receded by the 26 meters after the storm event. And then you can see how the beach recovered in the preceding months after it, quite slowly actually. And this section of the coast is still very vulnerable. Okay, so let's go to our last case study example. This is at Turrametta Beach, which is on the Sydney's northern beaches, just north of a beach called Narrabeen, if you've heard of that. So this is a very curious beach. It changes quite a lot between the summer and the winter months. Here's an example here of you can see how throughout a 12-month period, the beach narrows quite considerably. But what you can also see is a time-lapse video of beach usage at this location and how it reduces throughout the year as the beach gets narrower. So we ran our people counting algorithm at this location, and there's quite a lot of information that I think could warrant a PhD in looking at the impact of beach width on beach usage and how that may be applicable to sea level rise conditions where our beaches are going to be under more and more pressure and under narrower states, and how that might impact beach amenity. So you can see that there's a huge difference at this location between the summer and the winter months. Here's some results here of our people counting, where you can have a look at trends throughout a 12-month deployment. So the first thing I'll draw your attention to is this plot here, where we've got beach usage throughout the monitoring period, and we've got the daily maximum temperature, or how hot the day was, in this orange plot here. And the first thing that you'll notice is that the busiest day of the year coincided with the hottest day of the year. And this was shortly after our Christmas period. So very hot day, up to 40 degrees centigrade, and very high beach usage at this location. The next thing you'll see is, conversely, in our winter months around July, there was much less beach visitation, where there were not many people visiting the location, but also I'll draw your attention to it that the beach was in a much narrower state. So it's difficult to know whether beach usage was impacted by the width of the beach or by the temperature. Most likely it was a combination of the two factors. The next thing I'll draw your attention to is the busiest day of the week. Much like our example at Burleigh Beach, the weekend is the busiest day of the week. But conversely, the busiest time of day, if you have a look at beach usage throughout the day, it was more towards the afternoon. So once again, this is the fingerprint of different beach locations, and each location has its own flavor of how people interact with it. So just as a bit of a final application of the smart camera system, I'll touch on the use of the cameras for rip analysis and coastal lagoon management. So here's an example of some detections of wave breaking. This is using an algorithm developed by a New Zealander researcher by the name of Tom Shand. And this essentially looks for wave breaking pixels. And you can see it's detecting the waves on the left here, but what it's doing is it's building an intensity of wave breaking on the right-hand side here. And you can start to see some really noticeable trends in where waves are breaking, but also where waves are not breaking. And that can be associated with where rip channels are located. So if you have a look at a zoomed in plot here, here's a plot of wave breaking intensity over a week-long period. And the first thing you'll notice is these areas where there's no wave breaking, which is where the deeper water is and where the rips are more likely to be in these two channels here. And you can also have a look at where sandbanks are more likely located, because there's a higher intensity of wave breaking. So these have quite useful applications in understanding nearshore morphology of the coastal locations, and they can be unlocked using a very cheap $700 camera. The other thing you can do is look at how this particular location responded to storm events. And here's an example here of that same storm that happened in July last year. And you can see how this coastal lagoon changed quite significantly between the two. Now, finally, I'll touch on a dashboard system that we've been using to convey the results of our smart camera system to a client. So on the Central Coast, 100 kilometres north of Sydney, we've deployed 9 smart cameras, and we've built a dashboard in ArcGIS online dashboards for the client to look at the live feed from the cameras. So they can see a video and an image every 15 minutes, and also have a look at a time-lapse video of coastal change that's updated every night. And we host useful information on the right-hand side here, such as water levels in the lagoons, wave heights measured nearby, and also forecasts. And it's very easy for this particular local council to have eyes on the beach without leaving their office, which has been quite useful in the COVID lockdowns that we've had. And they're able to visit these locations virtually from their office. And they've found that to be very useful and use it on a daily basis. So that's a presentation of the camera system that we've developed. Hopefully it's a bit of food for thought to stimulate some interest around what may be applicable to the UK context, and how you may not need to use very expensive systems to still get some really useful monitoring data. So on that note, I'll say goodbye, and I'll invite some questions at the Q&A session later. Thank you.